In this lecture, we will discuss how to write a basic Hello World program. We will see uh, basics of how we can give ports in Verilog program. So let us start with module, writing a module. Then module name is half adder. Now we will do what? We will give the inputs. So we can give as in there are multiple ways to write it. The way I will choose here it is this. We will give input, whatever input you want. Let us say want to design half header, so we have variables a comma b comma sum for s for sum and c for carry. Okay, so a comma input, b comma output, because sum is output, so we will assign output to sum and output C. So that's how we assign our ports here. Now we wish to write here. Now I will be using for here gate level, data flow. So I will use keyword assign here. Assign, so over sum we know that sum is A XOR B in case of half adder, and so we are write it here also. We are uh, using data flow modeling. So we are using data flow modeling. In the lecture world we discussed there are four types of modeling. So the first, in data flow level of modeling, we use the keyword assign to give as a output in such a way in form of some predefined gates which we have. So I guess we assign to, we will assign this carry as we know A and B. Okay, there are some operators also, we will discuss about them. There is this operator is known as concatenation or concatenation operator. Okay, this operator used to concatenate, like let's say we have a comma b, and when we will concatenate, so initially we were having a as a 1 b 0 and b as a 1 b 1. So once we will concatenate them, the output will look as a 0 1. It will behave in this way, it will concatenate them. Okay, so that's how concatenation operator works. Right now we don't need the concatenation operator here, we will use that in full adder case. There we will see how to get this. We will have carry out and carry in on. So that is how we write it. Now we just write end module. Now we have to write a test bench code here. So module sorry half adder underscore tb. Now we need to declare all the inputs at reg type. So reg a comma b, and output as wires. So wire s comma c. These are data types, reg type, wire types. There are other types also that are some. Let me write them here. There are some other data types also. We have wire, we have reg, we have wand. If I'm not wrong, there is something of word also. I don't remember. There is some try also. Let me see once again. There are some data types. Wire, wand, war. It was war. Other is try. Okay, these are some data types which we use. We use this, we have when we have a try state something, or we use this wand, or sorry, just it is wa, and the wand war. When we want to assign the same objects multiple times, then we can use wand other than this reg wire. Okay, so we declare them as a reg type, that is we will take inputs from them and we will give output to them. Now this initial begin block we will give as hash 10, a equal to 0, b equal to 0, every time we will just let's me try it here. Sorry, we will have a dollar monitor sorry, percentage t, percentage b, and percentage b. So we will have a dollar time comma a comma b comma s comma c. Okay, uh, these are objects we have. Now we will have this. After 10 seconds we will have a equal to 0, b equal to 1. After 10 seconds we will have a equal to 1, b equal to 0, and after 10 we have a equal to 1, b equal to 1. Now we just write it as end module. Let's try to execute this program. Warning invalid module instantiation. Okay, understand. So we have to write half adder also. Half module instantiation I forgot. Half adder. So dut, and then we need to join all these things. Let me give a partition line here to differentiate between them. So now we will need to write a statement here. Dot a dot b dot s dot c to c. That is. Now let's try to do this. Invalid error module instantiation. I give a half adder tb. Why this is happening? Module half adder input. This is assign this thing. Half adder. Let me use uut. Let's see it will work. Warning error invalid module instantiation. Module half adder. Although it shouldn't be doing any kind of error, that was not reg type this fire dot a to a dot b to b dot s to s and dot c to c initial initial begin. So I made after 10 seconds this is a value. Let me write here display also so that we can see the display. Display. In the display we will write as a b sum carry. That's let me move it there. Now we have a b sum and carry. Okay, initially there was nothing at the 0. After 10 seconds we have a 0 b 0, so sum is 0 and carry is 0. After 20 seconds a is 0 b is 1, so sum is 1 and carry 0. After 10 seconds at 30 seconds the sum a is 1 b is 0, so we got sum as 1 and carry as 0. After 40 seconds at the 40 second the a is 1 and b is 1, so we get sum as 0 because 0 0 is 1 0, so we get sum at 0 and carry as 1. So that is how we, using tutorials point, you write a Verilog program of creating a half adder. We did not need any specific separate file for test bench. In the same program we can call the mod, create a different module. You can use this same in the very Xilinx Vivado also. You don't need to create any test bench file. We just need to do this. We could declare the reg type as ASB. This was for data flow modeling. Once we will see behavioral modeling, we will see how different it is in compared to data flow. Thank you.